Suppose R and S are two subsets of a universal set U, and then we know that the number of elements in U is 24, the number of elements in S is 12, the number of elements in the complement of R is 16, and the number of elements in the union of R and S is 18. And what we need to do is figure out the number of elements in R intersect S. So we're actually going to do this in two ways, but before we do that, we first need to figure out how many elements are in R itself, because right now we just know how many elements are in R complement. So let's do that first. Using one of the formulas from the last video, we know that the number of elements in R plus the number of elements in R complement is equal to the number of elements in our universal set. And we know these two numbers, so we can solve for the number of elements in R. This one is 16, and this one is 24, and therefore the number of elements in R is 8. Now that we know that, let's first solve this problem by using the other formula developed in the last video. So remember that that formula says that the number of elements in R union S is equal to the number of elements in R plus the number of elements in S minus the number of elements in R intersect S. So be careful here. We need to solve for this guy over here. And actually, at this point, we know the other three. So let's just go ahead and plug them in. So the number of elements in R union S is given to us to be 18. We just figured out that the number of elements in R is 8. Again, from the problem, the number of elements in S is 12. And then we need to solve for this last term here. And so let's simplify some stuff. So 18 is equal to 20 minus the number of elements in R intersect S. And now you can just do some algebra and you figure out that the number of elements in R intersect S has to be 2. So that's one way to approach this problem, is by using the formula that we developed in the last video. There's actually another way. We can also use Venn diagrams. So let's draw a Venn diagram to represent this situation. So here's our universal set U. We have two subsets, R and S. And what we need to do is we need to figure out how many elements are in the intersection. So when we did a problem like this before, we started by filling numbers in on the inside and then working our way out. But we don't know what that number is on the inside. That's what we need to determine. So what we can do is we can put a variable in there. So you can use whatever variable you want. I'm going to use X. Alright, so there are X elements in the intersection of R and S, and actually what we're going to do for this problem is end up solving for X. Alright, so now where do we go from here? Well, let's just look at the set R, that circle. We know that the total number of elements in that circle has to be 8. So if there are X of them over here, then that means there need to be 8 minus X of them over there. Because if I add 8 minus X plus X, I'll get 8, and we know that R needs to have 8 elements. We can do something similar for this side. So in S total, there are 12 elements. So X plus whatever is here has to be 12. So this part has to be 12 minus X. Alright, so now what do we do? Well, if you notice, these three sets that are here, they partition R union S. And so the number of elements in R union S is equal to this plus that plus that. So in other words, 18, which is the number of elements in R union S, is equal to 8 minus X, that's that part, plus X, plus 12 minus X. Alright, so then let's simplify that a little bit. So on the left side we have 18. On the right side, 8 plus 12 is 20. Then if you notice, we have a negative X and a positive X, so those cancel out. And then we just still have a negative X over there. So we get 18 is equal to 20 minus X, which looks surprisingly like this equation right here. And so if you solve this, just like we solved this one, we'd get that X is equal to 2. And X is exactly what we're looking for. It's the number of elements in the intersection of R and S. So either way that you do it, we get that the number of elements in the intersection R intersect S is equal to 2.